We're familiar with this, aren't we? This is a linear equation in two variables. And we know that linear equations in two variables have an infinite number of solutions. And those solution pairs, when we plot them on our rectangular coordinate system, those solution pairs, if we put them all there, would make a straight line. And remember, that's what we do. We take the equation, we find some solution pairs, we plot those points, we draw the line that intersects those points, putting an arrowhead at each end to indicate that that line continues on indefinitely. And this is the picture of that infinite solution set of this linear equation in two variables. If x was 1, 3 times 1 would be 3, 3 plus 4 for y would make 7, wouldn't it? If x was 2, 2 times 3 is 6, plus 1 would make 7. 3 times 3 is 9, minus 2 for y would make 7. Those are three solutions. That's how I got those points in order to draw the line that is the picture. Remember, the line is the picture of all the solutions of an equation in a linear equation in two variables. Now, that tells us that anywhere up and down the line, the ordered pair would solve the equation. But what about off of the line? What about the ordered pairs over here? Do they make that equation true? Does the ordered pair here for x and y make that equal to 7? No, only the pairs on the line. What about the pairs over here? Do the pairs over here, do the ordered pairs here make this expression equal to 7 when we plug them in for x and y? No, only the points on the line. Well, what about the points on each side? What do they do? What do they do to that original equation? They don't make it equal. What do they do to it? Well, let's see. Let's pick a point over here. Let's pick the point 3, 3. That's not on the line, is it? The point 3, 3. 3 for x, 3 for y would not be on the line. If we plugged in 3 for x, 3 times 3 is 9, plus 3 for y, that's 12. 12, well, how is 12 related to 7? Well, 12 is greater than 7, isn't it? Well, what about if we picked another value over here? Let's pick the point 4, 1. That point's not on the line, so what does it do to the statement? 3 times 4 is 12. 12 plus 1 is 13. 13 is greater than 7, isn't it? Is that an indicator that all of these points over here make this expression greater than 7? Well, it's not a proof of it, but that is the case. All of these points on this side of the line make the statement greater than 7. What about the points over here? If these points make it greater than 7, these points make 3x plus y equal to 7. What's your guess about these points over here? Do these points make it less than 7? Let's try one. Let's try the origin. That's an easy point to try, isn't it? If we put in the origin, 0, 0. 3 times 0 is 0, plus 0 is 0. 0 with respect to 7, 0 is less than 7, isn't it? What if we took the point 1, 1? 1 times 3 is 3. 3 plus 1 is 4. 4, indeed, is less than 7. Well, what about the point negative 1, negative 1? 3 times negative 1 is negative 3. Negative 3 minus 1 more is negative 4. Negative 4 is less than 7. That's true. So these points on this side of the line make it such that this quantity is less than 7. And understanding this fact, understanding these facts about the line and the points on either side of the line, help us understand how to deal with linear inequalities in two variables. This is a linear equation. But what if we had a linear inequality? What if we wanted to know what values of x, y make 3x plus y greater than 7. Or let's say greater than or equal for our first example. Greater than or equal to 7. What values of x and y make 3x plus y greater than or equal to 7? Well, the line is all the points that make 3x plus y equal to 7, isn't it? And what have we seen now? By example, this side of the line has the points that make 3x plus y greater than 7. So how do we show that graphically? The way we show that graphically is by what we call shading or marking this side of the line. And what we are graphically expressing is that all of these points, the line and the points on this side of the line, make that inequality true. The points on the line make 3x plus y equal to 7. The points to the right of the line make 3x plus y greater than 7. And this is how we solve, or this is how we express the solution set to a linear inequality in two variables.